Hello, everyone. My name is Andre, and I am the marketing manager for biologics here at Unchained Labs. I will be your moderator for today's seminar, and I want to thank you very much for joining us here this morning, this afternoon, this evening, depending where in the world you are. We will have a Q&A session at the conclusion of the presentation, and in order to ask a question, all you need to do is click the Q&A button in the Zoom navigation bar. It's either going to be at the top or the bottom of your screen, depending on your settings of your computer. Type in your question, and we will, of course, try to get to as many as we can at the end of the seminar. Please do not submit them anonymously, so in case we don't get to your question or we want to follow up more later, we can know who asked the question and we can follow up with you. Now, I am very excited to introduce my colleague, Nelis Dennis, the product manager for Stunner. I am really excited because he is going to show us, he's going to introduce us to the new rotational angle dynamic light scattering in Stunner. He will show us how Stunner can be used to characterize the quality and quantity of biologics. And Stunner doesn't only rule proteins, it's also applicable to ADCs. With this, I want to hand over to Nelis, and I'll see you on the other side. Nelis, floor is yours.
Thank you, Andre. Okay. Thanks again for that introduction, Andre, and thank you all for attending this seminar, Characterize Your Biologic Like a Boss with Stunner. I'm never gonna claim that I'm the most handy person around, but I can figure out how to get basic things done. But the problem with crafting or just doing general things, small things in your house, even if it's the smallest things, you're gonna need a good amount of tools to get things done. And they all have their own skill set and of course their cost. There are also a lot of things to analyze when you're doing protein characterization. Quantification and sizing are two essential parts of data to gather. UV-Vis and dynamic light scattering are established techniques to answer some of the questions you have. Are there any aggregates in my sample? How much protein do you actually have? And so on. But old school ways are one sample at a time, and they only provide answers on one or the other, resulting in more precious sample and hands-on time required to get all the data you need. And you need multiple tools to do that, and again, they all come with their own skills and their cost. Not to mention the extra time it takes to combine and analyze results from multiple instruments. And that's why I'm very pleased to introduce to you all Stunner. It's a one-of-a-kind instrument that lets you nail down your protein characterization by knocking protein concentration, size, detection of aggregates, and molecular weight of your list in one shot. And it also has unique solutions to give you information on your conjugates and to test for protein-protein interactions. So without skipping a beat, you'll know if your protein is good to go. Stunner is the only system that pulls together UV-Vis concentration, rotating angle dynamic light scattering, and multi-angle static light scattering data on the same 2 microliter sample. And so you just load that 2 microliter sample in a Stunner plate. You don't bother with any sample prep or dilution or anything like that. You just load your sample in. Our consumable has a microfluidic circuit with 2 fixed path lengths built into it to cover a wide dynamic range. And so if you're dealing with a full plate to fully characterize 96 samples, whether those are replicates or different batches of protein altogether, Stunner will gather UV-Vis data and light scattering results from 7 different angles, all in around 2 hours. Stunner's protein applications combine both technologies on a sample to deliver quantification and size and PDI results. And on top of that, our consumable is SBS format, so it can easily be loaded by any liquid handling robot, or you can even make the full instrumentation handling, so from loading your sample to actually setting up the experiment, loading the plate into the experiment, measuring, getting your data into LIMS, all of that can easily be automated. Here we can see exactly what sample loading looks like with the help of some fluorescein and a black light. In 2 wells, you can see that we've already added 2 microliter of that fluorescein. And now, as you can see, to load another sample, you simply add in that 2 microliter into the input well, and the sample will wick into the plate. Now, after the plate is loaded into the instrument, the circuit is read first when it's empty, and that will remove any absorbance contribution from the consumable itself. And then a pump applies a small vacuum, which moves the sample into the microcuvette to be read. Because our circuits have fixed path lengths, it can make very precise and accurate reads. Now, protein aggregates can be large and make your sample multimodal, and this will result in anisotropic light scattering, meaning your scattering is not the same in all directions. So you'll get different scattering results depending on the angle an instrument is looking at or is measuring at. Tiny bits of aggregates might not be visible yet with single angle backscatter DLS, but they would show up on forward scattering. Stunner has the ability to rotate the angle it does DLS at, so it gathers size and intensity data on your sample from 7 different angles and combines all of that to give you one clear size and intensity output that is angle independent. So it doesn't matter how large or polydispersed or multimodal your sample is, Stunner's RADLS technology has got you covered. And you might think by combining technologies that Stunner would give in on data quality, but nothing could be further from the truth. Stunner's UV-Vis is pharmacopoeia compliant with specs on accuracy within 2% of the true value and less than 1% on precision, 1% CV on precision. And our light scattering is top notch as well. So here we're looking at an antibody, which was measured in octuplicate. And as you can see, the percent CV on the concentration is 0.2%. And on the z-average, this was only 1.5% CV. So Stunner will provide all the DLS results you need with z-average, hydrodynamic diameter, and PDIs, but will also give you an intensity, mass, and number distribution with a quantifiable area under the curve. Now you no longer have to be limited by DLS data that has to be manually gathered for about a dozen pieces of data in a day. Stunner allows you to measure 96 samples at a time so it can keep up with your large amount of samples, or running as many replicates as you want, while giving you the full size distribution readout. And it also allows you to put that sizing data into context. We're looking here at a quantitative intensity and mass distribution on 2 proteins. They're both run in separate wells. And it's hard to spot since the lines are almost perfectly on top of each other, but both these proteins were run in triplicate. By not using normalized distributions, but quantitative ones, and by having the option to run up to 96 samples in one experiment, you can easily run replicates and compare them to each other, run all the statistics you want, or even compare completely different proteins side by side. Both proteins here had a concentration around 5 mg per mil, but thyroglobulin is a lot larger and therefore scatters light a lot more intense. So just comparing intensity distributions would leave you wondering how much of each you have here. Our UV-Vis will give you the answer on that, and also what you can see here is our quantitative mass distributions agree that in this case both proteins are at the same concentration. And so by using RADLS and its forward DLS angles, Stunner is extremely sensitive for the tiniest amount of aggregate, so they show up as soon as possible on your intensity distributions. We are looking on the left graphs at a pure antibody. One single peak can clearly be observed in both the intensity and mass distribution. Now we heat treated this same antibody until it was fully aggregated. Then we took a little bit of that aggregated protein and spiked 1% back in our pure sample to begin with. That's what showed on the right graph. You can see the clear difference on the intensity distribution, showing a big second aggregate peak at the moment we spiked that 1% aggregate. Now, if we switch views to a mass distribution, now you can also see how concerning that aggregate might be. It might be significant on an intensity distribution, but become almost irrelevant when looking at a mass distribution. So you can decide immediately on next steps based on all these outputs. Should I purify, or is this aggregation not significant, or whatever fits your process. And with our rotating angle light scattering, we also get static light scattering results at each of those angles. So an overall normalized intensity for each angle. That normalized intensity is called a Rayleigh ratio. This will give us a quick molecular weight output along with size and concentration to know as much as possible of your protein all at once. But also this static light scattering will give you an orthogonal check for aggregation. If this, what is shown a Guinier plot, is the normalized intensity across the different angles. If that's a perfect or horizontal line for your protein, it's nicely unimodal. If a large aggregate would start to form, the small angles, which are on the left of the graph, they will pick up the scattering of that aggregate and will start to increase in intensity, resulting in a Guinier plot with a slope. And so overall, another method to show that aggregation is forming. And then when you want to look at colloidal stability and overall protein-protein interactions in different formulations or for different protein, B22 and KD are known parameters. However, to get these results, you need concentration and light scattering data. Stunner is the only system out there that can get those needed data inputs all at once with our UV-Vis and light scatter combo, all from that 2 microliter sample. So combine this with our 96 well format, and you can really screen different formulations with B22 and KD like nothing else out there, all within the same experiment, and the software will calculate everything for you. So here we can see for a specific example that the succinate buffer for this protein had a positive slope for both the KD and B22. And therefore, there's less likelihood of this protein to aggregate in this specific buffer compared to the normal PBS. And that is not all. Anyone working with antibody drug conjugates or antibody oligo conjugate, or basically antibody anything that absorbs conjugates, you will know that characterizing your antibody conjugate is overall difficult. Well, those years are over. Stunner allows you to specify 2 spectra, and so that would be your antibody and whatever else that is conjugated. So that can be a drug, that can be an oligo, that can be a label of some type, practically anything else that absorbs. And the software will separate the measured spectra and will separate those spectra, and quantify both. So both your antibody and the other thing. So from that same 2 microliter of sample, and without any dyes or standards, you can get your antibody concentration, your drug or oligo concentration, and their molar ratio, all calculated automatically by the software. On top of that, you'll get a size and a polydispersity output from the light scattering. So you can see at which drug-antibody ratio your conjugate complex starts to aggregate, or just simply how big the impact on the size is by adding a conjugate to your antibody. All of this in our straightforward software, giving you all the outputs you need in a nice graphical interpretation with graph-specific outputs below each graph. By having the flexibility to compare different proteins or just overlay replicates, you can easily decide on the next steps for your samples. And of course, you want to check performance at some point. This fundamentals kit makes it easy to prove accuracy, precision, and linearity in the wavelengths most relevant for proteins, with 5 concentrations of aqueous L-tryptophan. These are all third-party certified. So since tryptophan residues cause most of protein's absorbance at 280, the fundamentals is an appropriate model for most protein applications. Each vial will come with a target concentration and an uncertainty, and so you can just put these numbers in the application before you run it, and Stunner will take care of all the calculations beyond that. The Fundamentals app will give you easy-to-read results per standard, and then an overall linearity across the whole series of 5. All this so you can easily check the instrument as much as you want. And we also have IQ/OQ procedures available, and Stunner software can be made 21 CFR Part 11 compliant with full audit trail and electronic signature capabilities and data integrity. And for labs doing manufacturing, quality control, quality assurance, Stunner has performance verification. These tests will meet the United States Pharmacopoeia and the European Pharmacopoeia guidelines for UV-Vis systems. And so the tests and all necessary calculations that come with it are handled, once again, automatically by the software. And so that is how Stunner gives you an all-in-one biophysical readout on concentration, size, aggregation, and molecular weight of your protein. Now, let's look a bit more in detail to some conjugate samples. We'll look at some data on an antibody with two different labels. It's an Alexa 350 maleimide and also Alexa 350 NGS ester. That's going to be used with the same antibody. So with Stunner, we'll take a look at how much and how big. Overall, how do you go about measuring quantity and quality of your antibody drug conjugate? So as mentioned earlier, the software allows you to see so much more than just an absorbance spectrum. You can easily define that your sample has this antibody and this specific label, in this case, the Alexa maleimide. And it will deconvolute the measured spectrum into the contribution of the different components, allowing you to quantify both and get the drug antibody ratio. Now, this was done for both mentioned labels and plotted on this graph. On the left, we can see the difference in drug antibody ratio for both labels. And we can see that increasing the mole ratio did increase the DAR in both cases, but a significant larger drug antibody ratio was seen with the NHS ester, even if they were added at the same mole ratio. Causes of this might just be an incomplete reaction or some other factors overall. And when we look at the impact on size, the graph on the right, which is the graph on the right, we can see that logically by adding in more labels that will conjugate, the size is going to increase. What can also be seen here is that the polydispersity starts to increase for the NHS ester, indicating that these are likely more prone to aggregate, or they are just caused by the larger drug antibody ratio. All useful insights on how good a conjugation reaction might have gone and how it affects your conjugate stability. And that is also what we see in the actual mass distributions of the samples. So the unconjugated antibody on the left is a nice narrow peak, and with increasing mole ratio of the conjugate, so the middle and the right, and the drug antibody ratio of the complex, we see the peak becoming wider and wider and the size overall shifting to the right. Getting all of this out of that 2 microliter sample in less than 2 minutes will give you crucial insights in your search for the perfect antibody drug conjugate combination and at which ratios. So step away from one by one and single solution instruments and start characterizing your biologics like a boss with Stunner. That's not all. We have a lot more tools built for biologics. We have Honeybun to measure viscosity in a high throughput, low volume manner. We have Unagi for fully automated buffer exchange or to simply up concentrate your samples. And we have Uncle as the ultimate stability platform, which allows melting and aggregation studies, thermal ramping, but also isothermal studies, all to really check out your formulations and their stability. So whatever you are doing with your biologic, check out our different solutions. I'm sure we have something to make your life easier. And with that, I thank you all again for attending this talk, and I'll take any questions now.
Awesome. Thank you very much, Nilis, for taking us through how to use Stunner with only 2 microliters of sample to quickly characterize quality and quantity of your biologic samples. Thanks also for the introduction to the brand new rotational angle DLS Stunner and how it can be used to determine Rayleigh ratios and spot aggregates in your biologics preps. People in the audience have been very active submitting questions. And before I start peppering Nellis with those, I want to say that if you're in the audience and you have anything burning under your nails, now's the time to type it in. Q&A button in the Zoom navigation bar at the top or the bottom of your screen, and we will get through it. So, Nellis, let me try to organize these a little bit so they're thematically together. Let's start with, how long does it take to read a plate?
So you have a bit different modes. So if you only want UV-Vis results, 96 samples will be about 10 minutes. If you do UV-Vis and the 7-angle DLS, it's going to be about 2 hours and 15 minutes for 96 samples. It's might be easier. It's going to take a couple of seconds if you just want UV-Vis on one sample. If you want UV-Vis and the DLS on one sample, it's 1 minute and 25 seconds approximately. So all very, very straightforward and fast.
Awesome, thank you. Another attendee asks, how many angles does the rotational angle DLS read?
So we have applications just to do single angle, or default for the RADLS is 7 angles, but you can actually specify up to 30 angles to measure at. So that's overall pick and choose, but our default is 7.
Okay, very good. Another or the two limit questions. First of all, what is the limit of detection? I'm assuming it's the lower limit of detection of stunner.
Yeah, so that's gonna depend a bit on the extinction coefficient of a protein, but in general, it would be around 0.03 milligrams per ml for the UV-Vis side of things. And then light scattering wise, it's the same across pretty much any instrument. So 0.1 mg per ml lysozyme is the lower limit there.
Okay, and lysozyme being, of course, about 15 kilodaltons in size.
Yes.
Okay. Attendee asks, can you load high concentration proteins, say 150 milligram per milliliter, or would you need to dilute those before applying them to stunner?
So because of the two fixed path lengths that we have a big dynamic range, up to 275 mg per mil for a generic protein. For an IgG, that would be around 200 mg per mil. So in your example, 150, you could just load 2 microliter sample and go. No dilutions required.
Okay, thank you. Question about that fundamentals kit. Are the standards sold by Unchained Labs?
Yes, we sell the fundamentals kit as a whole, but they are certified by a third party. So we don't make them in-house.
And then follow up on that, can you also use BSA or BGG, I'm assuming bovine gamma globulin standards?
Yes, you can practically measure any protein, but this is our standard that we found. But yes, where we have a specific application for. But of course, you can measure any other protein or any standards you might already have.
Very good. Question about KD. Do you need to load a gradient concentration sample to calculate the KD?
Yeah, so in this application, we would recommend 4 or 5 dilution steps indeed to get a gradient concentration dilution for calculating the slope on your KD. That's all built in the software as well. So with having the flexibility of doing 96 samples, you can easily do that even in triplicate or quadruplicate, and then even run other formulations on that same plate. That's the benefit of having 96 well options.
And I mean, I guess like the huge advantage is also that you measure your concentration at the same time as measuring your light scattering. So
yes. Otherwise, you would need to enter that data from a different instrument in your DLS system, which just makes it error prone.
Another attendee had a question about KD and B22 as well. Can the analysis be utilized for AAV, or are those too large for the laser wavelengths?
No, we actually have a specific AAV quant application. So definitely not too large. Our AAV quant application gives you tighter information, also aggregate information, empty full ratio information. So if you have interest in that, definitely reach out, I would say.
Yeah, I mean, from my own personal experience, I'm more of a protein person myself, but I think that for KDB2 or AAV, you would need pretty high titers to see an effect, but in principle, there's no technical limitation of stunner for this. Can you compare data across stunner plates?
You can set up multiple plate experiments, and in that way, it would open in the software all in the same experiment. So yes, but if you have separate experiments, you would have to compare the results later on in Excel, for example. But in a multi-plate experiment, yes, you could.
Cool, thank you. Question about the ADC that you showed. You mentioned that I can define what my drug is. How do I calibrate the system for this? And how can I calculate the molar ratio?
So basically, you don't really calibrate the instrument. There's a setting in the software that allows you to store a spectrum. And so if you have a specific drug you're using, you would need to make one small measurement, which takes about 10 minutes to obtain the spectrum of your drug. And then you can use that in any further measurements. When you do that, you also pretty much enter other information on that drug, molecular weight and stuff like that. And so the software will use all of that to calculate everything automatically for you. So only when you switch drugs, you would need to do it one time, and it goes very, very quickly. So
okay, very good, thank you. Are there any indirect viscosity applications developed on stunner? So viscosity by DLS essentially.
We don't have that. Our Honeyband system is a way better system for viscosity. Theoretically, yes, with beads and all, you can measure viscosity on a dynamic light scattering system. You have ways in our software to make your own type of calculations, which is called homebrew. But again, for accurate viscosity measurements, I would definitely refer you to our Honeyband system.
Well, good, thank you. Is there a 21 CFR Part 11 compliant mode in the software?
It's not, well, it's a mode is not the word I would use. You basically can activate it, and then everything you would do would be falling under our 21 CFR compliant software. So it's a license that activates the audit trail and the electronic signatures and all of that across the whole software.
Okay, I think that's what I would have called the mode. Okay, sorry for confusing you there. Can you use Stunner for semi-purified harvest material? I'm assuming they're talking about AAV here.
We have advanced mix, same like I showed with the conjugate. We have applications that look for contaminants in your sample. So depending which sample this was, if it was AAV or anything like that, we have specific applications that will look for impurities to still give you an accurate result on whatever your target sample was. But I think material is a bit too general for me to really say yes or no, we have an application for your samples.
Yeah, I mean, it's an analytical instrument, right? The more purified, the more reliable. But I mean, you can always try it and at different stages, see what you can see. Question about, and I'm a bit confused by the question, but I'm going to read it out so maybe you understand what they mean. There is the function to quantify his tag antibodies. Can you customize it to quantify other his tag proteins?
That was a specific application. Basically, yeah, you can customize a lot, definitely with the new conjugate application. And so we would need to chat afterwards to see what you want to do is feasible, but I would say yes.
Yeah, very good. DLS question, is there a recommended number of scans of DLS for each sample on Stunner? I guess it's the number of acquisitions is the question here.
So for the RADLS, the 7 angles, we've optimized it with 5 acquisitions and 1 second and 7 angles. But you can fully adjust it to what you want, of course. In single angle mode, you might take longer acquisition times and anything like that. But again, you can customize how you want it and save that setting for later usage as well. We found with our default setting that you get the best data that you need at that point.
Very good. And I'm keeping the most complex question last, Nellis, so be prepared. Will these slides be available later?
I'm happy to send out the slides as a PDF, and otherwise this whole presentation will be available online through our website and normally on our YouTube channel as well.
All right. Thank you very much, Nellis, for answering all these questions. And thanks again for the presentation and for introducing us to rotational angle DLS. I want to thank everybody in the audience for joining us today. If you would like to have a deeper conversation with us, with the Unchained Labs team, please reach out at info@unchainedlabs.com. And of course, you can also get all the information about our instruments and our solutions at www.unchainedlabs.com. We always like chatting with you, our users, and are very happy to keep the conversation going. Thanks again for joining us here this morning, this afternoon, this evening. Have a great rest of your Thursday, and see you all around. Thank you.
Thank you.